Hey there, and welcome to The Explainer. Look, if you work with LLMs, you know the feeling, right? One minute you get a fantastic result, and the next, it's completely off brand. The real challenge is getting those consistent, high quality outputs every single time. And today, we're diving into a really powerful way to do just that fine tuning. This quote right here gets to the heart of the problem. You've spent hours, maybe days, crafting the perfect prompt, but the model's output still isn't quite there. The voice is just a little off or the format's wrong. This is that moment when you have to stop being an instructor and start being a teacher. It's not about giving one-off commands anymore. It's about teaching a new skill that sticks. So here's our game plan. First, we'll talk about why prompts alone sometimes just don't cut it. Then we'll get into what fine-tuning actually is, the two main ways to do it, and, the big one, how do you choose? After that, we'll look at the trade-offs, the real-world costs, and wrap up with one clear takeaway you can start using right away. Okay, let's paint a picture that's probably pretty familiar. You're working with an amazing base model. It can write, it can summarize, it can even code. It's a total powerhouse. But for some reason, it just can't nail your company's unique voice. Or maybe it won't generate reports in that very specific JSON format your team needs. You're just stuck in this endless loop of reprompting, editing, and fixing things by hand. And this is the perfect way to think about it. Imagine your base model is a brilliant new hire, a generalist who can do a bit of everything and has tons of potential. But what you really need is a specialist. You wouldn't just hand them a different memo with new instructions every single day and just hope for the best, would you? No way. You'd enroll them in a dedicated training program to build that specific, repeatable skill. Well, that training program, that's fine-tuning. So yeah, that's precisely what fine-tuning is all about. It's the process you use to take that brilliant generalist and turn it into the expert you actually need, an expert that's perfectly adapted to work in your world. Okay, let's get a little more specific here. Fine-tuning is literally the process of changing the model's internal wiring, and you do that by training it on your own hand-picked set of examples. The key word there is examples. You're not just telling the model what to do in a prompt. You're showing it over and over, maybe hundreds of times, until that new behavior becomes second nature. And that brings us to a super important point. If fine-tuning is the training program, then your data, that's the curriculum. And the quality of that curriculum determines everything. Your success really comes down to three things. First, quality, because garbage in, garbage out. It's that simple. Second, size. You need enough examples for the lesson to actually sink in. And third, coverage. Your data has to show the full range of patterns you want that model to learn. All right, so you've decided you're going to train your model. But fine-tuning isn't just one thing. There are really two main paths you can go down. One is like a complete top-to-bottom overhaul of the model. The other is much more like a targeted, super efficient skill upgrade. So on the left, you've got full fine-tuning. This approach updates every single parameter inside the model. It's incredibly powerful for sure, but it is also massively expensive and very slow. Now, on the right, you have parameter efficient fine-tuning, or PEFT. This is way more surgical. You actually freeze most of the model's original brain, and you only train a small new set of parameters. This is so much more efficient, and honestly, for a lot of tasks, it's just as effective. And PFT isn't just one idea. It's this whole family of really clever techniques. You'll hear these terms thrown around like LoRa, QLoRa, and adapters. You don't need to be a math whiz to get this. Just think of them as different tools in a surgeon's toolkit. They all let you add a new skill by inserting these small, efficient little modules instead of having to retrain the entire brain from scratch. And that brings us to what is probably the most critical decision you're going to make. When should you actually use fine-tuning? Because it's a powerful tool, but it's also an expensive one. You should really only reach for it when the simpler methods just aren't working. So let's build a little framework for making that decision. Because, let me be clear, before you go and commit all that time and all those resources to fine-tuning, you really have to explore your other options first. And the two big ones you need to know about are prompt engineering and a technique called Retrieval Augmented Generation, or RAG. This table right here makes the choice so much clearer. Think of prompt engineering as your daily instruction memo. It's perfect for simple or one-off tasks. RAG is like giving your model a key to the company library. It lets it look up specific facts that it wasn't trained on. And then there's fine-tuning.
That's the Intensive Specialist Training Program. You save that for when you need to teach a deep, repeatable skill or behavior that instructions and reading alone just can't handle.
Okay, so let's say you've weighed your options and you think fine-tuning might be the answer. Well, before you dive in headfirst, you have to get real about the practicalities. Every single one of these methods comes with a price tag, and I don't just mean in dollars.
It's really this delicate balancing act between three things. First, there's cost, the actual money you'll spend on compute for training and hosting. Second, latency, how fast the model gives you an answer, which is absolutely crucial for any real-time app. And third, maintenance. A fine-tuned model isn't a set-it-and-forget-it thing. It's a living asset that you have to manage and keep updated. If you mess up any one of these, it could sink your whole project. And this chart, wow, it tells a pretty stark story, doesn't it? Prompting and RAG are your baseline. They're cheap, they're fast. But the second you move up to PEFT, your costs and your latency can easily quadruple. And full fine-tuning, you're playing in a totally different league. We're talking potentially 8 times the cost and latency. It's a massive jump, and it's exactly why you always start with the simplest tool that can possibly get the job done. All right, we have covered a lot of ground. So let's boil all of this down into a single, straightforward strategy that you can take and apply to your own work. Here it is. This 3-step workflow should be your golden rule. Step 1, start simple. I mean it. Always begin with prompt engineering and RAG. Squeeze every last drop of performance out of them first. Step 2, identify the gap. If that's still not enough, pinpoint the exact repeatable behavior the model is failing to learn. And then, step 3, fine-tune with purpose. Only then should you use fine-tuning with the single-minded goal of teaching that one specific pattern. If you only remember one thing from this entire explainer, please make it this. RAG gives your model knowledge. Fine-tuning teaches it a skill. RAG is for knowing what, fine-tuning is for knowing how. If you get that distinction right, I promise you, you will build smarter, faster, and way more effective AI. And that's our look at fine-tuning. You now have the framework to go beyond just telling your models what to do and to start really shaping them into the specialists that your work demands. So the only question left is, what unique capability are you going to teach your model first? Thanks for joining us.